in, um, opposite yung end, or in simple term, they are connected in series AD. Kuha. Kasi if ito, positive terminal of B2 is connected at positive terminal of 3. So, ang mangyayari is opposite ang connection. So, in this case, we have a positive, negative. So, in series AD position, so meaning additive, yung polarity. Intindihan yung equivalent supply. So, for this example naman, we have opposite, actually opposite. Kasi dito alternate yung polarity. So, negative, positive, negative, positive. So, in this case, for subtractive, siya alternative, or alternate, sorry. So, magkakaroon tayo ng equivalent subtractive formula. So, in additive, we'll just add B2 plus B3, buha. But in subtractive, depende sa connection. Okay, if we are going to apply KVL, for example, pero kahit hindi na KVL, sa KVL natin i-base para mas maintindihan. So, negative, positive, positive, negative. So, ito yung example natin, B2 and B3. Nakuha. For example, it is connected at terminal VAB, di ba? So, i-assume lang natin yung analysis per branch. So, it is certain branch lang. So, we are going to apply KVL. So, for example, ito yung loop direction. Hindi ba yung polarity for loop direction is dependent? Or sorry, the polarity of the given source is dependent on the loop direction. So, if we are going to get the equivalent polarity, saan lumabas yung loop? So, for B-sub 2, we'll get positive. For B-sub 3, going to get negative. Intindihan? So, in this case, we have positive B-sub 2 minus B-sub 3. Pero for example, kasi set kayo ng opposite direction. So, ang mangyayari dyan, we have opposite yung loop direction. So, kunin niyo yung positive B3 minus B2. Pero in assigning loop direction kasi, dapat pare-pareho in each branch. Nakuha? Kasi once na magpalit-palit, for example, nakabase dito yung ating polarity, counterclockwise. Dito sa kabila, may set kayo ng clockwise. Sa kabila, counter na naman. So, magkaka-iba-iba lang polarity yan. So, magkakamali na kayo. So, ang gagawin nyo na lang, in applying Millman's theorem, so, iset nyo yung common terminal, for example, yung connection at the top. Ito yung common, di ba? Set nyo as positive terminal. Then, at the bottom, set nyo na negative. Then, for the loop direction, pwede kayo mag-set ng counterclockwise. So, lahat yan applicable. Counterclockwise ang reading. Dito. So, we have a counterclockwise and counterclockwise reading. Naintindihan? Nakakasunod. Okay, so sige. For third branch, so we have a single resistance and single supply. Then for the fourth branch, we have a single resistor connected. So meaning wala tayong kailangan simplify pa. Okay, let's proceed to the next. Okay, next step is to calculate the terminal voltage AB is derived from the block. Okay. So from the given initial, wait lang. Okay. Okay, so let's proceed. So we have simplified circuit ito in combination. So we have branch number one. So for the branch number one, we have V sub one and series resistor R1 and R2. While for branch number two, we have a combination of V2 and V3. So since they are additive, then we have series connected resistor R3. And for the third branch, we have R4 and V4. For the fourth branch, we have resistor R5. Okay, to calculate the terminal voltage AB, so ito, okay, so we will apply this formula. The summation of uh, individual voltage divided by the resistance over summation of 1 over R. So initially, E over R is equivalent to I. Tama? Then 1 over R is the conductance, meaning the reciprocal of resistance. So initially, in getting the voltage, we usually I times R, di ba? Pero if we are going to change or apply the conductance in the formula, it is equivalent to I over G. So another formula for voltage. So in Millman's theorem, actually, derived formula na to. So hindi na natin i-derive. So what we're going to use is the derived formula. Intindihan? Then apply to the wait na. Hello, hello. Okay, sige. Okay, from the derived formula. So ito yung magsisilbing numerator natin. V over R stands for the individual voltage over the connected resistance on each branch. Naintindihan? So in this case, A sub 1 over R sub 1. So in this case, kasi yung derived formula natin is based from simplified circuit ito wherein on each branch, there is a single supply and a single connected resistor. So kumbaga ito yung ating connection. So we have the V sub 1, R sub 1, V sub 2, R sub 2, B sub 3, R sub 3. So actually, ito yung ating uh, based on the derived formula. Ito yung connection of the circuit. Naintindihan? So that's to be the dito, divided by summation of the conductances on each branch. So we have 1 over R sub 1 plus for the second branch 1 over R sub 2 and so on. Now if we are going to apply this formula to the given circuit, so we will have the equivalent formula. Okay, in this case, we have supply V sub 1 for the first branch and we have an equivalent resistance of R1 and R2. So divided by R1 plus R2, then plus the equivalent or the combined voltage of V2 and V3 divided by connected resistor R3 on the second branch. Naintindihan? So first branch, ito yung second, then we have the third branch. For the third branch, we have a single supply B sub 4 and a single resistor R sub 4. And for the fourth branch, we still have to apply the formula V5 over R5. Since there's only one resistor connected at the branch, so meaning in this case, or at the fourth branch, the peak voltage is equivalent to 0. Naintindihan? Okay. So, para mas maintindihan natin, i-apply natin sa sample problem. Okay. So, we have example problem. Use Millman's theorem to solve for the voltage AB. So, we have the terminal A and B. We have a common terminal. Then, we have a three parallel branches. So, actually, in this example, nag-set na rito ng value for each branch as sub 1. So, meaning per branch, we have an equivalent sub 1 value. Naintindihan? For the second branch, we have a sub 2. Then, for the third branch, naka-indicate na yung sub 3. Meaning, for the first branch, we have the first resistor R sub 1 and the first branch supply source D sub 1. For the second, so initially, we do not have A sub 2, meaning 0. Naintindihan? Then for the third branch, B sub 3 and R sub 3. Okay, so apply the Millman's theorem formula. So, from the initial formula. So, pwede nyo iset nyo as a guide. Diba? We have three branches. So, meaning, we have E sub 1 over R sub 1 plus E sub 2 over R sub 2 plus E sub 3 over R sub 3 divided by the sum of the conductance per branch. So we have 1 over R sub 1, 1 over R sub 2 is 1 over R sub 3. Okay. If we are going to substitute the following given to the derived formula, so okay, substitute natin yung mga values. So initially, okay, itong numerator natin, in terms of voltage, kasi importante yung polarity, tama? So we will set positive terminal across terminal A and negative for the terminal B. Okay, in this case, we will substitute E sub 1, which is equivalent to 32 over R sub 1, so 4 ohms, plus, again, E sub 2 is 0 divided by 2 R2. Then, in this case, kung papansin nyo, yung ating supply is in negative, sorry, in opposite direction. Compare nyo dun sa battery, wait lang, may kamali ako. Wait lang, edit lang. Yung resistor na yung supply. Sorry ka naman. Hello, hello. Okay, so continue natin. So, inayos ko na. Solution, so, rewrite. So, for terminal voltage AB is equivalent to E sub 1 over R sub 1 plus E sub 2 over R sub 2 plus E sub 3 over R sub 3 divided by the sum of the conductances each branch. So we have 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3. So ito yung ating formula. Then if we are going to substitute the following values, so E sub 1, battery 1 is equivalent to 32 volts over 4 plus, okay, this case for the second branch we do not have a source, so 0 over 2. Then considering the third branch, we have considering the connected supply which is opposite. So kumbaga gagawin natin set a positive and negative terminal both end terminals, di ba? So this case, if the polarity, the battery is connected along to the positive terminal of terminal A, so iset natin siya as positive. Naintindihan? kung nakaset yung negative terminal or terminal side of the battery, for example, for the third branch, we have the positive and negative terminal, di ba? It is connected on the terminal A with a negative value. So, gagawin natin, we're going to subtract the equivalent current for that branch. So, meaning, instead of positive, we're going to set sign as negative. So, for E sub 3, we have 8 volts divided by R3. R3 natin is equivalent to 4. Then, divided to the sum of the conductances. For the first branch, we have 1/4. The second branch, we have 1/2. For the third branch, we have 1/4. Okay. For the denominator, sum na lang tayo ng conductances. So, wala nang magbabago sa sign. Sa numerator lang. Okay, in this case, the terminal voltage VAB is equivalent to check na natin. So, we have a positive 6 volts. So, ito yun, terminal voltage. Ako ha, paano naman kung hinahanap yung current on each branch? We are going to the power across the 4 ohm resistor or R sub 1. So, take note, power formula can use V squared over R or I squared R. So, in this case, from the given value, we have a terminal voltage AB, which is 6 volts. Tama? Then we have parang nagbablur. Yan. Okay. So in this case, to get the voltage across resistor 1, so we're going to get the difference between the terminal voltage AB into the supply E sub 1. Kasi initially, di ba, if we are going to apply, kasi di ba, kung ito yung terminal A, terminal B, so we have a terminal voltage, VAB. Then if we are going to apply KVL, ang problema kasi rito in using Millman's theorem, we do not have the current direction. Intindihan? So, ang gagawin natin is to solve the voltage across the resistor 1 by getting the difference between the terminal voltage AB and the supply voltage on the given branch or on each branch. So, ang gagawin natin to get the voltage across resistor R1, it is equivalent to terminal voltage AB minus E sub 1. Meron na actually sa second terminal, second branch natin, wala tayong other source. So meaning, yung voltage R2 is the same with the terminal voltage AB. Tama? Kasi kung mapapansin nyo, parallel connected sila at the same terminal. So meaning, B sub 2 is equivalent to terminal voltage AB. Then for B sub 3, get the difference pa rin. So VAB minus, in this case, kung mapapansin nyo, Diba opposite yung direction? Sub 3. So if you are going to apply KVL, so get the positive polarity, the negative polarity. Or we can just jump. Nalilito kayo. Kunin niyo pa rin yung so kunin niyo pa rin yung difference. Yun nga lang, yung ating voltage E sub 3 will have a negative value E sub 3. Pero ang correct way kasi dyan is to up KVL. Naintindihan? So we will apply KVL for a counterclockwise loop direction. So get the positive terminal. So terminal VAB plus terminal voltage E sub 3. Pero yun nga lang, naging problema natin dito is na ine-neglect natin yung effect voltage drop dito sa V3. Pero initially kasi, kailangan natin ng current direction to determine whether positive or negative yung magiging value ng voltage drop at R3, di ba? Pero in this case, since sabi ko nga wala tayong current direction na kino-consider, so just get the equivalent difference. So, then take note for a negative or opposite polarity ng ating supply voltage to the end terminals. Kasi ito negative, positive. So, ito lang yung ating magiging tawag dito, reference. So, VAB plus E sub 3. So, in this case, if we have 6 volts minus E sub 1, which is 32, so it is equivalent to 26 volts negative. So for VAB, we have 6 volts positive. Okay, in this case, 6 volts plus. Supply for the third is 8. So we have a positive 14 volts. Naintindihan? So pwede nyo nang i-apply. Power formula. So V sub 1 is squared over R sub 1. So for V sub 1, we have a 26. So in this case, we have to neglect the effect ng polarity, ha? 26 over resistance natin. 1 ohm. So ito yung ating equivalent. Watts. Then for P sub 2, so 6 divided by 2. For P sub 3, 14 squared. Okay, in this case, 26 squared divided by 4 is 169 watts. For P sub 2, 6 squared over 2. So, in this case kasi medyo usually in Millman's theorem kasi talaga, ang hinahanap lang natin is yung common terminal voltage, AB. Naintindihan? So, for additional info na lang itong pagkuha ng power. Okay, let's try to another formula. Problem. Use Millman's theorem to solve the voltage across RL. So in this case, we have four branches. Nakuha. So for the polarities of the given sources, negative, positive, positive, negative, negative, positive. So solve the voltage across RL. Actually, ating RL is single resistor lang. So we can set this as terminal A and B. So using Millman's theorem, actually, if you're going to use other network theorem, yung Millman's theorem talaga pinakamadaling gamitin in solving for parallel connected or parallel branches. Pero in overall kasi mas okay sa kayo mesh analysis. Okay, so let's proceed to get the terminal voltage VAB. So since we have four branches, so for the numerator, considering the first branch, so E sub 1 over R sub 1. Actually, pwede nyo naman iset na yung polarity kasi mamaya malimutan. So pwede nyo na iset to as negative. So kanina lang kasi pinakita ko lang yung solution using the formula. Pero dito, pwede nyo na i-substitute directly. So for a different polarity, negative ang value. Then, okay, positive, positive. Positive, so plus E sub 2 over R2. Then again, for the third branch, we have a negative value. So E sub 3 over R3. Then, syempre, yung ating fourth branch, E sub 4 over RL, which is 0 naman. Pero pwede rin na i-rewrite. Pero pwede rin hindi na i-include kasi 0 rin naman. Okay, let's proceed to the conductances of each branch. We have 1 over R sub 1, 1 over R sub 2, plus 1 over R sub 3, plus 1 over R sub 4. So substituting the following values for the terminal voltage AB. So for E sub 1, we have 96 volts. Negative 96 volts divided by 240 ohms plus E sub B is 40 divided by 200 negative 2 minus 80 volts divided by 800 plus 0 over 192. So overall are divided by the total conductances. So we have 1 over 240 ohm plus 1 over 200 plus 1 over 800 ohm 1 over 192. So the terminal voltage is equivalent to check in. Okay, in this case we have 19.2. So, double check na lang. 19.2 volts. So, 4200, 800. 192. Okay. So, okay na siya. Okay, yung negative 19.2 volts natin, meaning from the initial uh, polarity assigned. Kasi ito yung formula based on the derivation. So, kung negative yung ating polarity, yung actual polarity is negative, yung nasa top connection below is positive. Naintindihan? Pero wala namang kasi. Kumbaga, in actual kasi, kumbaga measure lang din kayo ng voltmeter or ng voltage using voltmeter. Ito yung positive terminal nyo initially na naiset. So, ito yung reading from the digital meter. Negative 19.2 volts. Pero, kung pagpapalitin nyo naman yung polarity, so, maging positive na yung meaning nasa actual or nasa true connection kayo. Ako nga. Kasi hindi mas greater yung polarity or yung connection ng battery. Actually kasi we have 96 and 80 like that, the same side. While yung 40 volts natin is at opposite. So meaning, sa taas yung battery pressure from or coming from voltage is at 1 and is at compared to 40 volts. So sa case naman na to, wala namang problem. Okay? So actually, yung ating sample problem is ito na. For additional info lang yung Millman's theorem. Pero kasama siya sa final exam ha. Okay? So i-post ko na lang din. So, saan na tayo? Set tayo ng important dates. Ako ha? Okay. Thursday, December 3. So, that time meeting. Then, December 8 and 10. Ang problema rito, magkakasabay-sabay na sa exams. Okay, for the coverage. So, exercises lang tayo sa Thursday. So, hindi na kailangan mag-meeting. Ha? Then, for December 8, Tuesday, final quiz 1. So, ang coverage nito, isasama ko pa rin yung wait lang. Hello. Okay, so may tanong ba dun sa schedule natin? Actually, yung ating lang problema kasi yung exams natin magsasabay. So, yung coverage for final quiz 1, ibabalik ko pa rin yung mesh nodal. Teka lang, i-superposition. Then for the final quiz sa Thursday next week, coverage, uh, wait lang, ito. So, delta y transformation, Thevenin's and Norton's theorem. Then yung final exam natin, so yung coverage superposition hanggang ito, Millman's theorem. So ito yung ating coverage for the exam. Nakuha. For the quiz, mesh nodal and superposition. Then for Thursday, delta y transformation, Thevenin's and Norton's. Actually, ang problem lang natin dito sa halos pareho lang sa ating lecture. Kung meron mang pinagkaiba, siguro pwesto lang ng resistance. Okay, so December 15 na ating final exam. So medyo magsasabi kasi, akala ko kasi aabot tayo ng 17. Ito sana yung part 1 and part 2, 15, 17. Pwede tayong mamili ng date. Kaso hanggang 16 lang ata ang klase natin. Ano bang nakalagay sa inyo? May schedule na kayo ng mga final exams?
Wala po, sir.
Wala pa. Pero ayun, yung klase natin ng TTH malamang ito rin yung schedule. Kasi hindi na tayo makapag-adjust. Kung gusto niyo, mag-quiz tayo ng mesh nodal tsaka superposition sa Thursday. Pwede rin pala. Kasi natapos na natin ito eh. Kayo, okay lang ba sa inyo? Kasi sasabay ito sa subjects nyo ng mechanics. Mechanics at economy. kasi tayong specific na formula rito. Ito na lang ata may formula tayo eh. Di ba? Sa hindi. Yung delta y transformation din meron. Sa mesh nodal, superposition wala naman tayo formula. Siguro ito na lang. So sa final exam, i-allow ko lang kayo magkaroon ng formula sa one whole band or short band paper lang. One whole short band paper lang ang i-allow ko. So, formula lang, walang solution. Ako ha? Pero sa final exam na yun. Wait lang. Check natin ulit. Okay, sige. Siguro hindi ko na isasama to. Hindi ko na isasama. Yung mesh at nodal. Ay, yung pala tayo nakapag-exam ng nodal, no? Di pa kasama yung nodal ng midterm exam, no? Mesh lang pala yun. Kailangan talaga siya. Okay, sige. Ito yung ating coverage. So, paki-take note na lang. Ako nga.